Hello, my name is Alper. We are Soft Art. Our senior project is about automation of traditional Turkish tile art çini. What is Turkish tile art? Turkish tile art is a traditional art form practiced for many centuries. The art of tile making is born from the urge of beautifying everyday materials with colorful drawings. To make tile art requires expertise, patience, skill, and time. With this project, we plan to shorten the time and allow the artist to concentrate on the creative aspect of this art form. The phases of Turkish tile art making. Artists first sketch their motif on a draft paper. Use needles to pierce these traces dot by dot. Pass on these traces onto ceramic by rubbing cold powder on the draft paper. Later retrace the outline of the past motif, which is called tahrir in the profession, and lastly painted.
This is very tiring, but we solved this problem. Our solution consists of two components. The first one is the software component and the second one is the hardware component. We build a needlehead plotter, but before using the plotter, the image should be manipulated. We use open source image editing tools and also we developed our own software. Our plotter to produce draft papers fast and accurately. Additionally, our plotter can produce multiple draft papers in one run and can repeat the same process at different times. Our needlehead plotter machine. Plotter machines are much like regular printers we use every day. However, principally they differ from printers. They work in continuous motion to draw a line, whereas inkjet or dot matrix printers work by drawing the picture dot by dot. The plotter should be able to follow continuous lines obtained from the image, but convert them to discrete intervals to place dots where needed. For this, we developed a method of conversion for dot placements and a custom-made needlehead for piercing the dots. How did we solve the problem? Transform the image and generate G-code. Notify the G-code and send the G-code to the plotter to perform the punching. Image transformation. For image transformation, we shall use open source vector image editor Inkscape. Using the editor, the image can be converted to flat tracing lines. The tracing lines are then converted to G-code using GTEC Photonics extension tool. G-code stands for geometric code. It is the language understood by the plotter. In other words, G-code is used to orchestrate the plotter to operate in three dimensions, namely x, y, and z axis. Plotter is controlled by an Arduino microcontroller which instructs the motors where to move, how fast to move, and what path to follow. G-code transformation and visualization. Now we have the G-code. If we use the G-code as it is, it tries to draw arcs, and when we use a needlehead, it will cut the paper instead of punching holes and possibly damaging the head in the process. It is not what we want. We want to have dots and discrete moves instead of continuous movement of the needlehead. We developed software for transform the G-code into notified G-code to make sure that the result is suitable for the plotter. We shall use Comatics simulation software designed for CNC machines to simulate the changed G-code. You can see the simulation of the finalized and dotted G-code on the screen. G-code and plotter. The verified G-code sent to the Arduino microcontroller connected to the plotter by Universal G-code sender durable firmware installed on Arduino drives the motors and components on the plotter, which produce the dotted draft paper. Plotter machine. A basic hierarchy of the plotter machine can be described as Arduino as the brain of the plotter, takes the movement commands with the help of gerbil firmware installed on itself acting as a translator for G-code, and tells the motors where and how to move in X, Y, Z coordinates. While the CNC shield placed on top of Arduino I/O pins provides the power needed by the motors to operate. So the desired motif can be punched on the draft paper by these components of the plotter. Other parts of the plotter which are not mentioned on the slide are mostly structural or supplementary components such as aluminum extrusions, steel rods, welds, power supply unit, and etc. The plotter machine cost us somewhere around 1000 Turkish liras. Conclusion. In this project, we automate the tile preparation process by building the needle head plotter to punch holes corresponding to an image. This saves time for the artists who then focuses on the more creative phase of the tile art making. One important advantage of the automation is that the plotter can stack up draft paper, therefore can produce multiple papers in one run. Thank you for listening. Do you have any questions?